Hello. Today, we will look at IACS Recommendation 194, officially known as Cybersecurity Controls for Existing Ships. In other words, we will examine the cybersecurity controls for existing vessels. In this video, I will easily summarize within 10 minutes why RECS 194 was developed, which vessels it targets, and what the 14 key control items are. First, let us look at the background behind the development of REC 194. Recently, the digitalization of ships has been continuously progressing. Functions such as navigation, propulsion, steering, alarm monitoring, ballasting, and cargo handling are now operated through various computer-based systems and networks. In addition, digital application systems such as scheduled maintenance, remote diagnostics, equipment inspection, and condition-based maintenance are also being used. While these changes enhance the efficiency and safety of ship operations, they also simultaneously increase the potential for exposure to cyber threats. The key subject here is existing vessels. Newly built ships can incorporate cyber resilience requirements from the design stage. However, for vessels already in operation, cybersecurity may not have been sufficiently considered at the time of their initial construction. For example, IT and OT networks may not be clearly separated, the inventory of onboard systems may not be systematically managed, or procedures for remote access and USB usage may be lacking. Therefore, there is a need for cybersecurity controls that are realistically applicable to existing vessels as well. The purpose of REC 194 can be summarized in a single sentence. It is to present minimum cybersecurity controls designed to reduce the likelihood of cyber incidents on existing vessels and to mitigate their impact in the event of an incident. It is important to note here that REC 194 does not replace UR-E26 or UR-E27. While REC 194 is a recommendation within the IACS framework for cyber resilience, it does not replace the unified requirements applicable to new vessels. In other words, REC 194 should be understood as a practical standard indicating that it is desirable for existing vessels to possess at least this level of cybersecurity controls. So which vessels does REC 94 cover? In REC 194, existing ships refer to vessels for which construction contracts were signed prior to July 1, 2024. The scope of application is, fundamentally, for vessels exceeding 100 GT. However, inland waterway vessels, warships, and government vessels operated for non-commercial purposes are excluded. From a systems perspective, REC 194 views both IT systems and OT systems as potentially vulnerable to cyber threats. However, the core targets for protection are, in particular, OT systems and the areas where OT connects with IT systems. The core of REC 194 consists of a total of 14 cybersecurity controls. These 14 items are broadly divided into 5 functions. The first is identify. This is the stage of identifying what needs to be protected. The second is protect. This is the stage of protecting the identified systems from cyber threats. The third is detect. This is the stage of detecting anomalies or abnormal behavior. The fourth is respond. This is the stage of determining who will respond and how in the event of an incident or malfunction. The final is recover. This is the stage of restoring the system to a normal state after an incident. The first area is identify. The item corresponding to this is the vessel asset inventory, or the list of ship assets. REC 194 recommends maintaining a list of onboard OT systems. This list can be a handwritten list, such as in Excel, or a list generated using tools like an asset scanner. The important thing is not simply to list the equipment names. Key attributes, such as the type of equipment, manufacturer, software version, and patch status, must also be managed. Simply put, this means that you must know what digital systems are on board the vessel to ensure protection. Next is protect, the protection area. This section contains the most items in REC 194, and its core purpose is to protect the vessel's OT systems from cyber threats. The protect area includes network protection, malware protection, access control, wireless communication, remote access, USB and removable devices, training, system updates, and maintenance. In other words, it should be understood not simply as the concept of installing a single security device, but as a concept of protecting the entire operating system, encompassing networks, equipment, accounts, access, personnel, and maintenance. First is network protection. Some existing vessels may have been constructed without sufficient consideration of the risks associated with the connection between IT and OT. Therefore, Rec. 194 recommends separating OT systems from other zones and implementing traffic monitoring, real-time alerts, IT-OT separation, and crew zone separation through firewalls or security devices. Next is antivirus protection. While antivirus software or other protective measures may be considered to protect against malware, antivirus software should not be installed arbitrarily on OT systems, unlike on general office PCs. The principle is to apply such measures only when permitted or provided by the system vendor. Next are access control, wireless communication, and remote access. First, access control encompasses both physical access control for equipment rooms, control panels, racks, etc., and logical access control such as accounts, passwords, permissions, and authentication. Next is wireless communication. In an OT environment, wireless communication should be used restrictively whenever possible. In principle, critical services such as propulsion and steering should not be connected wirelessly. Finally, there is remote access control. While remote access is convenient for maintenance and diagnostics, it can be a significant risk pathway from a cybersecurity perspective. Therefore, multi-factor authentication, authorization, encryption, session termination, and connection log records must be managed together. Next are USB training and maintenance. First is USB protection use of portable devices. USB drives and removable storage media are major entry points for malware in a ship's OT environment. Therefore, it is recommended to block unused ports and to inspect portable devices before use. Next is training. This training is not merely security awareness education, it is designed to help crew members understand OT-related cyber risks, system malfunctions, and related procedures. Finally, there are systems updates and maintenance. System updates and maintenance must be performed by authorized personnel according to a pre-agreed schedule, and change management records must be maintained. Next is detect. The corresponding item here is network operation monitoring. Rec. 194 recommends having sufficient monitoring, diagnostic, and logging capabilities to detect anomalies. What is important here is not simply storing logs. You must be able to detect abnormal communications, unexpected network activity, and system malfunctions. In other words, the core of the detect area is to establish a system capable of recognizing anomalies early, rather than only becoming aware of a problem after it has occurred. Next is respond. There are two items here. The first is responsible persons ashore, that is, the onshore manager or contact point. There must be a company contact point capable of supporting the captain and crew in the event of a cyber incident or system malfunction. Since it is difficult to resolve all problems on board the vessel alone, it is important to be connected to an onshore support system. The second is reporting. There must be company procedures and reporting forms regarding cyber incidents or malfunctions. In other words, when an incident occurs, it must be determined who, when, in what manner, and where to report it. The final step is recover. The first item is backup and systems restore. For OT systems, equipment redundancy or backup and restore procedures may be required. The important point is not simply to store backup files, but to be able to restore the system to a normal state in the event of a failure or accident. The second item is incident detection, response, and recovery. A procedure is required to detect system anomalies or errors, respond to them, perform measures such as network isolation if necessary, and then proceed to recovery. In other words, the recovery domain refers not merely to fixing problems when they occur, but to a systematic procedure that extends from detection and response to isolation and recovery. To summarize the content so far, IACS Rec. 194 is a set of recommendations for cybersecurity control items for vessels in existence. The core consists of a total of 14 items. It requires identifying the vessel's OT assets, protecting networks and systems, detecting anomalies, responding to incidents, and finally, being able to recover. Furthermore, this entire process is not simply a matter of installing a single piece of equipment. It involves creating a cybersecurity framework where technology, procedures, personnel, and records management work together. As the digitalization of ships continues to advance, cybersecurity is becoming a critical standard for safe and stable operation on existing vessels. Rec. 194 can be viewed as a practical starting point in that it presents cybersecurity controls that are realistically applicable to existing vessels. In other words, understanding Rec. 194 means understanding what to identify, how to protect, and how to detect, respond to, and recover from threats on existing vessels. I hope today's video has been helpful in understanding IACS Rec. 194. Thank you.